Hey guys, it's Byte and a Half. I thought I'd do a tutorial on an important C++ feature and also an important feature in MCPE modding. This feature is called vtables, and I've had a lot of questions how vtables work, what they're for, and basically I'll give an example. So we have a class here called A, and inside of A we have an int for data, and we have two functions: int get data, which will return this data, and print message, which prints out this is A. And then we have the A constructor, which sets data to 4. Now down here we have another class B, which extends from A, and B basically, the B constructor will call the A constructor, and then it sets data to 0. So B's data will be 0. Then inside we have another function, get data, returns 6, and print message, which says, dude, this is B instead of this is A. And then down here in main we have an object called A, and an object called B, and they're of type A and B respectively. So we call this function fun, and fun, its only parameter is an A pointer, but since B extends A, we can use a pointer to a B object there as well. But since get data and print message are not virtual, it will automatically use the implementation for A, since it's of type A pointer. So when it says A instance print message, the compiler is going to hard code in there A print message and call that no matter what. And same for here, A get data, it's going to hard code that in there since it's of type A. So when we call when we use our A instance in there, it's going to call A print message, which is going to go, since it's hard coded, it's going to go to A print message, and it's going to say this is A. Then when it says, it will print out A get data, which is hard coded, so it's going to go up here and say 4. It's going to print out A's data, which is 4. Now when we pass in B to fun down here, you would expect it to call the functions of B instead of A. But the problem, however, is that since these are hard coded in here as A, since the functions are not virtual and it takes an A as a parameter, it will explicitly only use A's functions. So even when we pass in B, it is still going to print message, and it's going to print this is A. And then when we print data, it's going to print 4, because that's what, or no, actually it'll print 0 because B sets data to 0. So it's going to print 0 here since it's hard coded. But if these functions are virtual, get data and then virtual void print message, then what's going to happen instead of hard coding these is that each of these objects are going to get a vtable at the beginning of their class structure. So instead of data being at 0, they're actually going to have an implicit pointer to their vtable. We'll just say uint pointer vtable, which is going to be at 0. Vtable is always at the start of the object, and then 4 bytes in is going to be where data starts. So basically, since the functions are virtual now, instead of hard coding for A here, it's actually going to use a lookup for the vtable of that object. So when we pass in A, it's an object of type A. So it's going to go it's actually going to look in A's vtable, which is at the beginning of the object, and it's going to look for the pointer to print message in that object. which this is a vtable for A, this is a vtable for B. I just kind of wrote them in here just so you can see what they look like. So it's going to use a print message in the A vtable, since it's an object of A, and it's going to print this is A, and then it's going to print out the data from A's vtable, get data, which is going to return 4. But then when we pass in with B, this is where you're going to see a difference, is that even though this is an A pointer right here, it's actually, since the functions are virtual, it won't actually hard code A itself. It'll just look in the vtable for that object. So it's going to look in the B vtable now, and it's going to look for its implementations of print message. So B print message in the vtable, and it'll say, dude, this is B, and then it will look for get data in the B vtable, which is right here, and it will return 6 right here, because that's what B's overridden get data function tells it to do. So now, if we look in the case of MCPE, this is just an example of how MCPE uses vtables. So for things like blocks, here's the base block class, and basically the block vtable gives blocks all kinds of their properties and their features and stuff and their functions. So this is not actually what the vtable looks like, but this is just an example. The block vtable will have things such as get in the block's texture, the name, use, which is when you right click or tap on the block, it'll call that, and it will do something when you click on the block, basically. For instance, doors will override this so that they will open and close when you click them. It'll also have the block shape, color, neighbor change, which is when a block next to the block changes, and it will basically call that so that it'll update this block if it needs to. So these are examples of classes that override from block. Is slab block, so it'll override the pointers for texture, because all slabs have different textures, all slabs have different names, and shape, since the slab block is actually half the size of a normal block. And then the redstone wire block class might change the texture, since it has a different texture, shape, since it has a different shape, color, since redstone wire block changes color depending on its power, and neighbor changed, so that the redstone wire will update when other redstone wire or redstone torches around it change, basically. So that's what that's for. Now, if we go here, we'll open up an example. This is for Windows 10 edition, but for Android or iOS, it would mostly be the same. This is our code for our mod, and basically we're just going to do a basic vtable hook. So if we go and open Windows 10 edition in IDA, and go here, we can look for a vtable, which we're just going to use dirtblocks vtable. So this is the address. It would be the address of the first pointer. So you just go across, and it would be this, but don't use the 014O, just everything, the 6 digits after that. So that would be the pointer to our dirtblock vtable. So now we're going to make a static vt, or static, gotta give the type, uint pointer t vt dirtblock. So then we'll set dirtblock now to dirtblock equals cast uint ptrt slide address, which is a function I have here, right up here, which basically just adds the base address of Minecraft Windows 10 edition to the offset. So slide address, and that's our address for our dirt vtable. And then basically what you would do is look in the vtable for various functions. You might have to compare to the Android version to tell what these pointers are, because the Android version has symbols, but the Windows 10 and iOS versions don't have symbols, so they just all say sub with a number. But if you compare to the Android version, you can figure out what the functions are pretty easily. I'm just going to use 59, which is right here, and it returns OFFFFFFF, which is get color. So that will determine the color of the block. So if we override that in the vtable, in this case it's the dirt vtable, so vt dirt block 59 equals ptrt, and then we're gonna use our own function, which we'll just call get dirt color, and then we'll make a function up here for that, int 32t get dirt color, and we will just unsigned. We'll return our own color, which is going to be in format ARGB. So the first is alpha, which is transparency, so we'll just do 0. 0 for red, 0, or we'll do full green and full blue, which should make like a teal color block kind of. So now we have a teal block set for our color. So we have, let's see, we're getting the vtable, overriding the pointer here. Okay, so this should be good now. We're going to build the mod. Oops. Silly me. I should say return. So now I'm going to build the mod, and then we're going to open Minecraft, and then we'll, just so you can see, we'll go in here so you can see that everything is as normal. Yeah, I was testing a mod down there, as you can see, with all the saplings and trees. There's the Insta House mod over there. Anyway, so we'll just go back to the title screen. Now we open Process Hacker, find minecraft.win10.dx11.exe, right click, miscellaneous, inject DLL, our mod. Now, when we go into the game, you can see that dirt has turned a teal color, which actually looks really cool. And it doesn't look like that in hand. I think you'd have to use different code in order to make it do that in the hand. But as you can see, any dirt that you place, it's anywhere in the world, not just right there. You can see all dirt is that teal color now. So that's about the gist of it. That's how vtables work in simple terms, and how to override functions in a vtable for a PE mod to make certain things such as blocks do what you want them to do. Yeah, I think that's all I had to say. Alright. Thanks for watching, guys. See you later.